Awesome. Hello, everyone. Good to see you all again. Bye, Kyle. Who's me? Yeah. As soon as I started talking. This is week 8, right? Yes. This is week 8. That means we are officially over halfway done with the school semester. Not necessarily in terms of days, but in school days. Which is kind of crazy to think about. I was thinking about that this morning, which does not feel right.
Only a senior would be counting like
I mean, if you want the hours and days and minutes, like, theoretically someone might be able to do that too. But thank you for all for being here. I know middle of the semester is busy, so we're glad you're here. We're excited for the talk. This is a super important one. I'm really excited for this talk because I think it's one of the most beneficial ones to know. I really love the fine-tuning argument. I think it's super helpful to talk about. We were whiteboarding today. A lot of you stopped by. Thanks for stopping by. We had some good conversations. If you have stories of conversations or any questions or anything like that, don't hesitate to ask us after. We'd love to hear them. That'd be beneficial for us. Let me pray, and then we'll bring Carl in. You all know Carl, so I don't need to give him anything. But bow your heads with me, and I'm going to pray. Lord, thank you for tonight. Thank you for the gift of gathering and snacks and meals and fellowship, that we can laugh with one another, that we can talk with one another. But most of all, Lord, we just thank you for this world that we live in. Everything about it that you have made, you have designed so carefully. We are so grateful for it, and we're so grateful to be able to learn about it. So help us to do that this evening. Help Carl to speak clearly and effectively. May we retain what we hear. May it not just be interesting, but then leave us tomorrow. I pray that it would stick with us, and then, as always, that we would learn to use it well for your glory. So bless this evening, and in your name we pray. Amen.
All right, well, good evening. Well, so just for the benefit of a few of you who don't know me, so I'm the assistant director for this chapter of Christi. But beyond that, I have been a science educator in one fashion or another for the last 42 years. So I'm always interested in science and what science can tell us. My background mostly is biological. So I have a bachelor's in wildlife biology, and I have a master's degree in entomology, which is insects. So I like the kind of biological side of things, but I think what we're going to camp on a lot tonight is the physical science kind of stuff. But that's not unrelated to biology. So I do have an interest in that as well. I also have a master's degree in science and religion. So thinking about the philosophy of science, philosophy and how science and religion go together. So I'm interested in those dynamics well. That's why I like Christian apologetics and thinking about, what do we believe and how do we know these things are true. And so tonight we're going to be exploring the fine-tuning argument for the existence of God. So our kind of general approach tonight is, first of all, to just take a look at the claim. What does this argument claim? And it's really important for us to focus on the claim. What is it actually trying to do? Because sometimes when we get into arguments, we kind of bunny trail off in different things. And we need to make sure we're focused on what the argument is trying to do. So I want to spend a little bit of time talking about what do we mean actually by fine-tuning. But I'm not going to spend a long time on that. I'm just going to give you some good examples of fine-tuning, what we mean by that. Where I'd like to spend a little bit more time is just as we think about the argument itself, is to actually look at the arguments against or challenges to the fine-tuning argument. This is where I'm going to put you guys to work, okay? So I'll give you I've picked 6 challenges or objections to the fine-tuning argument, and I'm going to put those out to you guys to think about, talk about in small table groups, and to see what you guys can come back with. Because I think that's a good way to wrestle with the argument. To some degree, I think everyone goes like, this is a slam dunk, duh. So it's good to look at some other perspectives and see where the challenges are for the argument. And then we'll wrap up with some conclusions. What are the so whats about this argument? So what is the claim? So the claim, first of all, for premise 1, is that the fine-tuning of the initial state of the universe is either due to physical necessity, chance, or design. Those are the three things that we use to it's overarching. This is how we explain things in the world. And so it goes on to say then, the fine tuning is not due to necessity or chance. Therefore, we're only left with one other option, and that is design. That the best explanation for our universe is that it is designed. So what do we mean? What are we talking about? What is this fine-tuning that we're thinking about? So we'll wrap back around to this claim, to this argument, and see how well we're doing with this. Because this conclusion here is only valid if the premises are right. And the one we probably need to focus on more is this really the case? Is the fine-tuning really not due to physical necessity or chance? But what is fine-tuning? Now, there's two kind of pathways to take on this. And so some people will really focus on what we call initial conditions. What are the things that had to be set at the beginning of the universe to get the universe that we have? And if you want to explore this kind of thing even more, a couple books I'd recommend. So Hugh Ross, of Reasons to Believe, wrote this book, The Creator and the Cosmos, and he goes over this at length in this book, where he's really focusing on the astrophysics kind of stuff. This one is also a really good book. It's called A Fortunate Universe. It's an interesting approach to thinking about the fine-tuning, because one of the authors is an atheist and the other is a Christian. And they kind of have this back and forth dialogue talking about these issues of fine-tuning. So I recommend that book. But the other way to think about fine-tuning is what I call local conditions. So we're going to start talking about the initial conditions. So what we mean by initial conditions, we're thinking, okay, what are those measurable parameters for both forces and particle relations that are necessary in order for us to get atoms? And then ultimately, how do we get the whole structure of the universe? What things have to be true for that? So here's what we're going to take a look at. There you go. Is that enough for you? So Hugh Ross, the guy who wrote this book, he's an astrophysicist, and he's kind of keeping a list of all the different things that physicists are uncovering about our universe, different characteristics and constants that have discrete values to them. And we keep uncovering more and more of these. I don't know how badly this dates me, but even characteristics of quarks. But quarks were actually discovered in my lifetime. When I was 8 years old, they had evidence for the first quarks. And so since those days, just every time we turn on, we're getting more and more data about that. Well, so he's listed on his website 140 different things. We don't have time to do 140. So let me just give you a sampling of what kind of things we're talking about. So first of all, we think about the strong nuclear force. Familiar with that? So what is that, in case you're not sure? So this is that force deep down inside an atom that resists proton repulsion. So we have protons that all have positive charges, and like charges want to do what? They want to repel each other. And so, but what's interesting though with the strong nuclear force is it actually has some characteristics of being an attractive force as well. Down inside protons, we have quarks. And quarks have both positive and negative charges, up and down quarks. And so some of them are having this tendency to repel each other, and some have this tendency to attract each other. And how do you keep the quarks from collapsing into each other or completely repelling each other? So depending on what scale you're looking at, the strong nuclear force is doing different things. And what's important is not only that it's the strongest force in the universe, it also has a short reach. And this is also important. So it's not just setting how strong this force is, but how far does it have the ability to reach? So these, I have no clue what these units are, okay? But here we're talking about, so in this, we're talking about inside a proton, okay? Here we're talking about inside the nucleus of an atom. That's as far as it can reach. It can't go beyond that. So what if? What if this force was stronger? What kind of effect would we have? So physicists have estimated that if it's only 4% larger, what happens? We get no hydrogen. That's a big problem. Okay? In biological systems, every time you turn around, you're looking at hydrogen ions passing back and forth across membranes. It's huge. And so we wouldn't have any of these stable nuclei. And then what if it's smaller? Well, if it's smaller than that, then what happens is the protons are very successful at repelling each other, and the only thing we get is hydrogen. So either way you go on this, it's bad news. Okay, so there's this just rightness to the strong nuclear force. But we also have the weak force. We don't think too much about that unless you guys are into nuclear chemistry and things like that. But these are forces that are influential in what's going on with nuclei and the interactions between up and down quarks. Because these forces are influential in both radioactive decay and also fusion. How we get progressively larger and larger atoms in fusion reactions that occur in stars. So what happens if we change the strength of this force? Well, if it's any larger, then we get too much hydrogen turning into helium, and we get too many heavy elements. And we bypass, we don't get enough things like carbon and oxygen, the smaller elements. But then if it's smaller, then we get not enough hydrogen converting into helium, and so we don't get any of the really heavy elements, which are also necessary. Even things like uranium, we would never get. We're going to see later on, like uranium actually is essential for you to survive on this planet. You actually have to have it. We'll come back to that. Another force is the electromagnetic force. Now, of course, in engineering, you do E&M, and you're well acquainted with electromagnetic force. So this is all about those attractive and repulsive forces in charged particles, right? But what happens if it's larger? Well, it doesn't matter if it's larger or if it's smaller. We can't do chemical bonding well. And you and I exist because atoms make chemical bonds and we get molecules. And so we cannot be larger or smaller than that. And I was trying to find a scale for that. How much smaller, how much bigger? And I couldn't find that. But it's very, very small. And then what about gravity? We all know about gravity. And the thing that's interesting with gravity, we talked a lot about gravity. These are just interactions between mass objects, and it's one of those great mysteries of physics, right? We can put formulas to it and describe how it works. We're still a little bit at a loss of what it is actually. But the interesting thing with gravity is, like the strong nuclear force has a very small reach. Gravity has massive reach in the universe in terms of its effects. So it's been estimated. So if we change how strong gravity is, we have some really big impacts on what happens with stars. Stars, in order to exist, have to do this balancing act between gravitational forces that want to take all the matter in a star and compress it to the center. And then we have the gas pressure from the heat being let off by the fusion reaction that wants to push the matter apart. And so there's this constant balancing act between that. So if it's too large, then we're not going to be able to release the heat as rapidly. And so the fusion reaction is going to speed up, go faster, and stars don't last as long. But if it's too small, then the stars are too cool to actually get to a fusion reaction. So we get no heavier elements. We would not exist. So either way, we're in trouble here. So it's been estimated that if it varies by 1 to 10 in the 60, 1 part per 10 to the 60, anyone have any grasp of what kind of number that is?
What's the amount of atoms in the universe?
Nearly, I mean relatively, we estimate number of atoms in the universe is about 10 to the 80. 10 to the 80. But still, I mean, that's the kind of number that we're dealing with. So the variance on this force has to be very, very finely tuned to be producing elements. Then in terms of the subatomic particles, so what about mass ratio between protons and neutrons? Now it's a funny thing because we always, on the periodic table, we think about, okay, neutron has a mass of 1 and a proton has mass of 1, neutron has mass of 1, but it's not quite right. Okay, there's a slight difference in the mass. It's a very, very small percentage. It doesn't become consequential in figuring out things in terms of atomic mass. But neutrons are slightly heavier. They have slightly greater mass. And so the thing is, in terms of when the universe was cooling right after the Big Bang, if there was any slower cooling than what we got, we would end up with 7 times more neutrons. In other words, they would have collected more mass. And so what happens to our chemistry? What happens to our periodic table if you have this abundance of neutrons over protons? That becomes a big problem in terms of forming atoms. And so it's been estimated that if this mass ratio, so if massive protons were 0.1% more massive, we'd have too few nuclei for any heavy elements. But if we do it the other way around, if it's less, then we'd end up with too many protons. And then what happens? Then the stars collapse, and we get a bunch of black holes and neutron stars. It's a problem. And one of the interesting ones is, as cosmologists look back, we think about, in the universe, what is the ratio between the number of protons and the number of electrons? So we're thinking that at one point in time, there was this reaction between matter and antimatter. A lot of that just collided and disappeared. And we ended up with a certain number of electrons and protons. But the ratio matters. And it's been estimated that accuracy needs to be 1 part in 10 to the 37. If there's 10 to the 80 atoms, the actual number that varies is a pretty big number. But you distribute that over the course of the whole universe, and it's a really, really small amount that makes a difference. And so this then influences the electromagnetic force when we have these different charged particles. And in both cases, we have this imbalance where we have electromagnetic force overcoming gravitational force, and what happens to an atom? We don't coalesce matter, and so we don't get galaxies, stars, or planets. We're not here, right? The last one I'll take a look at is expansion rate of the universe. So here's from Stephen Hawking. He says if the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million million, 10 to the 17, it would have recollapsed before it reached its present size. On the other hand, if it had been greater by 1 part in a million, the universe would not have expanded too rapidly for stars or planets to form. So how fast matter is expanding since the beginning makes a big difference. So that's just a sampling of some initial conditions. And what do you grasp from all of those? Even though we're not looking at all 140 that Hugh Ross has cataloged. Just from these 7, you get an appreciation for what's happening with the fine-tuning here. It's like very, very small changes in these ratios or forces makes gigantic differences in the universe. And we just don't even get universes out of that. So let me shift to some examples of what we call local conditions. So local conditions, this is what's needed to have life on a planet. So that's what I mean by local. And so these things, they're going to be dependent on initial conditions, obviously. We can't talk about local conditions in a universe until we have a universe. Okay? But these don't necessarily follow from those initial conditions. These are contingent. They don't have to be this way. We don't have to get these conditions to get life on the planet. It's not necessary. And the other thing to think about these local conditions is that they're time-bound. They didn't happen from the beginning. They appear over time and not all at once. And that's going to have some implication we'll talk about a little bit later on. But they're not all happening at once at the beginning. Right? So as the universe expands and galaxies form and solar systems form, all of these things don't happen all at the same time. So kind of keep that in mind. So one of the things we think about, so this is where Goldilocks comes in a little bit more. We think about Goldilocks zones. So there are Goldilocks zones in galaxies. It does matter where you are in a galaxy. Most places in a galaxy are inhospitable. But it's not just where you are in the galaxy, that both the type and the size of galaxy that you are in matters. Also, and the reason why everywhere is not safe is because in the center, what is in the center of most galaxies that we know now? Black holes.
Supermassive black hole.
Massive black holes. So you get a lot of cosmic radiation coming out of the center of black holes. So we don't want to be in the center of a galaxy. So where you matters. And it also has to do with where do we get concentration of things like the metals and heavier elements occurring. So matter is not evenly distributed in galaxies. So where you are matters. Also, time matters. You know that in the very earliest galaxies, we wouldn't have expected life because we would not have yet had any supernova that would have produced heavier elements. So time matters. Okay. Now, what's also just kind of an interesting side benefit to being where we are, which doesn't have anything to do with life, but being positioned out in an outer arm like we are in the Milky Way actually lets us have a view to the universe. If we were more in the center of arm, the sky would be obscured by too many stars and we would not be able to see the rest of the universe, which is interesting. That positioning also just conveniently makes it possible for us to discover the universe and even know some of the things that we're talking about here tonight. So you're inside a galaxy. So somewhere in there, we have to have a solar system that forms planets. And so here's another kind of Goldilocks zone where we talk about planetary habitable zones. And so a number of things matter here. So first of all, the kind of star, not any star will do. Because really, really large stars don't last long. They only last a third to a half of the time that our star lasts. The massive stars that end up going supernova, they're only going to last for 4 to 5 billion years. Whereas ours has already lasted, we think, about 4.5 billion years. And the type of long wave and short wave radiation differs. How much, so we don't like a lot of short wave radiation, the amount of ultraviolet light and gamma rays and X-rays that are coming at us. And these are dependent on how large a star you are. But so our star is actually average. E for average. Average is good. But then can't be just anywhere around that star. How far you are out from the star matters. And so that's kind of what this diagram is trying to depict. That we have to have something close to a star that is our one solar mass star, and then we're in this zone here to be able to have life. So you can't be too close because, well, you're too hot. You're getting too much radiation from the sun, and you can't be too far. So so we got a planet that's habitable, but there's other planets in our solar system, and really all of them we think have played a role in making Earth habitable. I'm just going to pick on Jupiter because Jupiter has really played just a gigantic role in forming the dynamics within our own solar system. Because of its mass, one of the things that Jupiter did in the history of our solar system is it cleared 99.9% of the debris in the asteroid belt. Now, despite the pictures that we see that people put of solar systems, and they show all this scattered debris in the asteroid belt, makes it look like there's a lot there. There's not actually a lot there. If you could take all the matter that's existing now in the asteroid belt, you couldn't even form a small planet. But it wasn't always that way. And so with the force of gravity from Jupiter, it effectively cleared the debris from the asteroid belt. Now, here's the question: where did it all go? Some of it came to us, which is really interesting. So as our planet coalesced, what is our planet mostly interiorly? Iron. So in the center, in our core, it's mostly iron nickel core. And then in the mantle, what do we have mostly? Aluminum silicate kind of material. But that's not what we need for life. We need things like carbon and oxygen and nitrogen, some of these more volatile elements. So they actually were scattered onto the surface of our planet from the asteroid belt. And Jupiter had a role in doing that, of distributing that material to the surface of our planet. And we'll kind of come back to that a little bit. So when we think about carbon, which we need for life forms on this planet, this is where this is coming from. And Jupiter had a big role in that. But now, okay, so our solar system is formed now. Does it still play a role? And we say yes, because we still have stuff that's extra solar system mass that's coming into our solar system because of gravity. And that's dangerous for us. So we have all these big brother planets out there that are, have high gravitational pull that's sweeping the outer parts of our solar system and taking the hit from those. Now, there was some report recently that said there is some kind of asteroid that's maybe coming our way and might hit the planet, but it's really small. It'll have some effect, but it's not going to kill us. So most of the dangerous stuff has really been taken care of by these large outer planets. Well, so then we also have a moon. Does a moon make a difference? Do we care about a moon? Well, one of probably the most important things that our moon does is it stabilizes the tilt of our planet. So our planet's tilted roughly 23.5 degrees. And there's a little bit of wobble to that. So we think historically that's probably our best explanation for the various ice ages that we've had, is that the tilt of our axis has tilted upward more so that the upper latitudes and closer to the poles didn't get as much solar energy and they freeze over. But if we didn't have a moon and our Earth was free to wobble, it could go all the way through 90 degrees. And where would we be in terms of climates on this planet? This planet would be completely unlivable if we didn't have that change. Then, of course, we know day to day that the moon is responsible for producing tides. And that's more than just the water comes up on the beach. There's importances to that because one of the things it does, it helps churn water in the ocean. So nutrients that kind of tend to settle down at the bottom of the ocean can get churned up and be available for things that are living more up at the surface. But it also has some impacts on freshwater hydrology. Any hydrologists in here? No hydrologists in here. So even the action of moving water in and out of groundwater sources, like in springs, actually can have some influence in that. And then, of course, a side benefit, maybe not as critical for life, it is a nightlife. As a wildlife biologist, I know that vast majority of mammals that live in North America, the reason we don't see them is because they come out at night. They don't come out during the day. And they've adapted to living in a nighttime environment. But the other one is eclipses. We have this really, really curious thing with our moon. Our moon is at just the right size and distance from Earth that it will nearly cover the sun during an eclipse, a solar eclipse, which allows us to see the corona. And the amount of stuff that we have been able to learn about solar furnaces and things like that have only been possible because of that perfect fit that we have. So it's just kind of a nice side benefit, not important for life. Water obviously is a big one. Astrobiologists who are looking around the different galaxies looking for habitable planets, the number one thing that they're looking for outside of are you close enough, you have the right sun, and the distance from the sun is could there be water there? If there's no water, it's a no-go. And I'm not going to detail all the important things of water, but we know that it has a number of properties that are unique to water. It can't be said of any other molecule on the planet, but make it essential for life. One of those being that it's a source of hydrogen, which we mentioned earlier. Hydrogen becomes essential for biological systems to function. And we get the hydrogen from breaking apart water molecules. And we also think about our atmosphere. So again, our atmosphere, how do we get our atmosphere? Our atmosphere was accumulated from matter that came out of the asteroid belt that was sprinkled on the surface of our planet because of influence of Jupiter. But what matters here? So what matters here is, so we know, middle school science, what's in our atmosphere? Nitrogen, oxygen mostly, a little bit of carbon dioxide, okay? But what's important here is it's not important just the proportion. That's what you probably learned in school. Nitrogen is about 80%, oxygen a little about 18 to 20%. It fluctuates. But it's not just the percentage that matters; the amount matters as well. So we say down here on the surface, the proportion of oxygen is about 18%. What is it at the top of Mount Everest?
So, more nitrogen.
It's 18%. It's the same percentage. So why do you die on the top of Mount Everest? It's about pressure. Inadequate air pressure to be able to do gas exchange across your lung membranes. You can't breathe because of inadequate pressure. So it's not just the proportion of gases, it's the amount of gases to create adequate pressure to be able to breathe. And we need these gases for a lot. 80% of the oxygen or the air is nitrogen. This is our primary source in biological systems for things like proteins and DNA. It's not coming from the ground. Its original source is from the atmosphere. Oxygen, we would say, what do you need, our students, what do you need oxygen for? To live. Fire. Fire. Yeah, we do. So it's real important in metabolism, but it's actually really problematic. Cells have to really be able to control passage of oxygen in and out of cells because oxygen is a highly volatile chemical. It likes to react with things. So cells have to kind of control how much oxygen is coming in and out of the cell to function properly. But it's real important for metabolism. But the other thing it's really important for is ozone. Ozone is what? O3. O3. Now there's good ozone and bad ozone. With our volatile chemicals here on planet surface, we generate ozone, and that's no bueno. But up in the stratosphere, our atmosphere is naturally producing ozone. And how do we benefit from that?
UV protection.
UV protection. So about 98% of the ultraviolet light from the sun is blocked out by the ozone layer. What does ultraviolet light do to us? Why cancer? What's it doing?
It's DNA.
It's breaking up DNA. It's destroying DNA molecules. Unfortunately, because we're only getting a small percentage of that, your cells have the ability to do some repair work if it is damaged. But what if we had no ozone? We would be fried. We would get no DNA. And then CO2, everyone gets worried about CO2. Do we need CO2 in the atmosphere? Yes. Okay. Because this is a heat-absorbing molecule, and it does help maintain the heat in the atmosphere. If we had no CO2 in the atmosphere, the warmest day on the planet would be sub-freezing. We're done and done, okay? But the other thing is that CO2 also becomes the source of carbon for ecosystems. That's where it's coming from. It's not coming from the ground. It's coming from the atmosphere. So we need to push back when people say nothing comes out of thin air. Actually, you did. This is where all this stuff came from. It actually originated in the atmosphere. Okay? Now, so I mentioned earlier, we need stuff like uranium. Okay? We actually need, so we have a great fear in America of radioactive isotopes. You don't like them, but you couldn't live without them. Okay? Why? Well, because the radioactive decay that's going on inside the Earth is actually the heat source inside the Earth. This is doing a couple important things. What's heat inside the Earth doing? Geologists, do you know?
It's making Steamboat Springs a lot of money.
That's true. So one of the things we think about is mantle convection. All right. So this is the driving force behind things like plate tectonics that become really important in terms of continent building, also in cycling different molecules in and out. There are inorganic cycles of things like carbon dioxide. Carbon dioxide tends to fix with calcium in the ocean and sinks to the bottom. And it's constantly stripping CO2 out of the atmosphere. Well, how do you get it back in the atmosphere? Well, we get subduction zone at the edge of...
Burn some lizards.
Yeah, at the edge of continents, and it goes back in, becomes molten, comes out volcanoes. Okay, so these are important. But another thing that's really important is this. This is the heat that helps generate a magnetic field. So we have material that is going around the solid iron core, and we think this is what's generating magnetic field. Why do we need a magnetic field? Well, it's actually worse than cancer. What's it do for us? What's this magnetic field doing for us?
Protects us against solar.
Yeah, so we have high-speed charged particles zinging out at us from the sun. And the magnetic field deflects this. If we got a solid hit from the solar wind that comes from our distance from the sun, it would completely strip away the atmosphere of our planet. And it would also damage all of your DNA. This is not good. So word of warning, any of you planning on doing that trip to Mars and like living there? Okay, one. Okay, so one thing I never hear anybody talk about about going to Mars is how are they going to protect themselves from solar wind? Because Mars does not have a magnetic field. We think it probably did at one point because we see some evidence for water erosion on the surface. So it must have had enough atmosphere, warm enough atmosphere to have a water cycle, but no more. It's a dead planet as far as magnetic field. So this is essential to life. Okay, so those are just some samplings. Okay, and so the question when we think about local conditions is when we think about how planets form, even within a galaxy, what happens? We get a supernova, so we get a star that explodes. We have this random mixture of elements from hydrogen to uranium, and they get pushed around by other supernova waves, and it coalesces into a mass, and it starts moving, it flattens out, and we get a solar system. Nebular hypothesis, right? And so this matter starts coalescing into the planets. And so we have to think about, okay, what are the odds? What are the odds that this planet is going to actually end up with the right amount of radioactive elements inside the core? Because if you have too many, what happens? Well, we're too hot. We don't have a cooled surface. We don't have plate tectonics. What if it's too cold? Well, then we're like Mars. So what are the chances that you get this right mixture? What are the chances that you get the right amount and proportion of carbon, oxygen, nitrogen populating the surface of the planet? What are the odds of this? And we'd say the odds are astronomical. Right? Okay, so back to the claim then. So what do we think about this? Okay, so we're saying this is how we account for the things in our universe. It's either physical necessity, chance, or design. And we're thinking, could these things, all of those initial conditions, could they have all happened by chance? And then even later, these local conditions, could they have all come about by chance? And what do you think the consensus is amongst physicists? No. The probabilities are just, we say, vanishingly small. If we get to a point where, so even Luke Barnes in an essay that he wrote, he just takes 3 of those constants, measures the probability out, and it's like 1 to 10 to the minus 137. And just with 3 constants, you instantly outstrip all the probabilistic resources of the entire universe. Done and done. You don't have to talk about 140. Just 3 of them will take care of it. So it's vanishingly small, so it's not chance. And do we have a sense that these physical constants are necessary? Do they have to be that way? Or are they contingent? Could they change? Could they be different? Okay. Well, there's no good evidence that says they have to be, they're necessary. And so physicists toy around with the idea of, that's where some of these statistics come from. Physicists play with the what if game, and they do the math and what would happen. Because we only have one universe to look at, right? So they're pretty sure that these constants are not a necessity and it's not chance, and therefore it's due to design. Now, here's where we need to get down to brass tacks, because this gives you the impression that this is like an inductive argument. I don't think it's quite inductive. I think it's more appropriate to look at it as an abductive kind of reasoning. And then what we're really looking at is which best explains the universe that we're in. Is it naturalism? where everything just happens by chance? Or is it theism, where it is by design? There is an intelligent agent that conspired to put all these things together in a just so manner. Okay, so questions at this point before we start looking at objections to this argument? Yeah.
Can you just flesh out a little more? I feel like I didn't quite catch how there's an argument that the initial conditions are not due to physical necessity.
Well, so we don't have any good, we can't look at any other ultimate law that would force these constants to be what they are.
So there's just no reason to say it has to be this way.
No. So it's like we're open parameters. They could be different. Right? Yeah.
Stephen Hawking was talking about the expansion rate of the universe and
Right.
how it has to be just so. But he was apparently not convinced by the fine-tuning argument. As far as I know, he was an atheist till he died.
Oh, he was solid atheist to the day he died.
So why was he not convinced? Do we know?
Well, I think that's a philosophical commitment, not a scientific commitment.
Yeah.
And so if you're not open to a God in the universe, then it doesn't matter what evidence you have in front of you.
Okay.
So I think it was more his philosophical commitment. Of course, he was a horrible philosopher. He was quoted as saying, "Philosophy is dead."
Well, that's interesting.
Like, are you sure about that? Because even that's a philosophical statement.
What about philosophy of science?
Whoops. Okay. So here's what I want to do next. So I'm going to have you guys get into 6 groups. So we got like 1, 2, 3, 4, 5, 6, something like that. So you can spread around if you want. But let me run through 6 objections here, so you kind of get a flavor of the kinds of ways that people object to the argument, and then I'm going to give you one. Your group is going to get one of these to see if you can wrestle with it a little bit. Okay, so I'm going to skip these. We'll come back to these. So because we're running out of time. So one is what's called the observer effect. I kind of hinted at this a little bit. The whole idea that, how many universes have we observed? 1. And how many of the universes that we've observed are life permitting? 1. And so they're saying, well, it's just because we happen to be living in that universe. And so we don't really have. So the question is, so where exactly is this fine-tuned? Where are you getting that from? Okay. The second one is this idea that actually the universe is too fine-tuned. So they say something like this. So if God's all-powerful, and he could have created any world he wanted to, he could have created a world in which life could have existed without all this fine-tuning garbage. Right? Life could just have existed. Period, without all this fine-tuning stuff. All right? So they're kind of pushing back on the whole idea that God would even make a universe that is fine-tuned. Why would he do that? And then on the other perspective, there's people who will say, the universe is not fine-tuned enough. We look out in the universe, how many planets out there have life on them? Well, as far as we've seen so far, we've got 1, could be others. It doesn't look like, it looks like if there's life elsewhere, it's really, really rare. So the thing is, so why is that the case? Isn't that a little wasteful on God's part? That he wouldn't have made more places, if his goal was to make a life-permitting universe, why don't we see life more common throughout the universe? Okay. Another one, people try to go this direction and say, well, we just don't know yet, but as physicists keep looking, one of the things we're going to do is we're going to find this underlying law that actually does constrain all of the laws that we know now that are not ultimate, and actually show that all of these constants we think are open parameter actually are necessary because of this deeper law. Okay? And then one has to do with probability, because that's what we talk a lot about when we're thinking about fine tuning. What are the odds of this? And so we're thinking about, and particularly if you guys are familiar with Bayesian kind of statistics, so we're comparing, what's favorable versus what's possible, but belief and subjective things actually can come into Bayesian probability. So we're thinking, on naturalism, we'd say that we've got this known observer containing world versus what are all the possible worlds that there could be. Big number. Compare that to the same kind of world that we have, but compare that to all possible worlds God could create. Some people will say, well, that's the same, isn't it? It's an equal probability. Okay, that's an objection. And of course, you probably heard multiverse. Okay, people will use the multiverse. They say, okay, so there exists this vast ensemble of universes. Maybe, I don't know about infinite universes, but like a lot of universes out there. And they have all varying constants and conditions within them. But if there's a sufficient number of them, guess what we'll get? One of those universes could be our universe. And so we don't have to worry about these really low probabilities. If we've got a whole bunch of universes, problem solved. Right? Okay, so those are the problems. Anyone care which one you get to work on? Yeah, okay. All right, so I'm going to hand out these. I don't know if you guys want to join another group since you're just two.
Without the chance.
You guys want?
Well, I'm least good at.
Let's see, do I get?
Okay.
3, 4, 5. Okay, wait, 5. That's fine. Well,
Basically, this one is
all right, I'm going to give you like 5-10 minutes. I'm not going to give you a long time. See what you can do with that. How do you counter that objection to fine tuning? Or maybe you can't.
I don't get why this is the problem.
More than I ever got.
Yeah, the most relevant one I can think of.
Anyway.
I could maybe see
Well, the problem is like, if we say the odds are like so,
like the wave function.
but if
Basically,
given enough
it's a conversation of like,
circumstances, then
are we
like,
predetermined?
how do we know it hasn't been trying
Go a
to
step further,
create
like,
this like situation
future.
from alternatives eventually?
It's like,
That's
you get to the relationship from that, and it's kind of like,
So really what we're trying to do here is we're making a comparison. This is between naturalism versus theism. Okay. So we're looking at which one has the best probability. And people are looking and saying, those two are the same. Because how many worlds could God create?
All of us did make a whole
All
bunch.
of them, right? They're making, he could make every single possible universe that we're talking about here. And therefore, same probability.
it doesn't address the probability question.
That seems like it's getting into the question.
Yeah. When he said world, find universe, world or universe?
Very specific. spitting out the universe.
So, what I'm thinking with the
We haven't found yet one more well that's suitable for mine.
and the Big Bang is when it finally succeeded or something.
Oh, right, it only addresses one.
And again, like it always
They say that the universe
and then I also
the
would
Big Bang came out of nothing, which
are you
implies not even quantum fields or whatever that does
Right.
probability.
But then you can actually change.
Yeah, because we would expect.
Yeah, exactly. So,
How would
yeah, if somebody
work
said
we'd expect.
to me what you said, I'd say, still have to solve the problem.
How would you measure our universe?
What made it go bang? Why does anything
We
exist?
would expect it to at least what even started the trying.
Yeah, so I think this is, it has to be assuming,
A rising natural.
it's after that point, assuming we had a big bang, matter exists, now what? Except
Observation.
that for matter to exist, a lot of it is those concepts we're talking about.
So in this case, it just makes a lot more sense
Change
for,
one of the human
like,
sites.
for God to be just repeated, right?
What if you change one?
Because yes,
Could you
there
probably
is
say
theoretically
change one?
there's non-zero chance, but
Would that be
our
right?
calculators can't give
I
us
think
that
that's kind of
answer.
like
Like,
right.
Yeah.
That is like,
I suspect
oh,
the
well,
super
we change this
computer
over here, we
can
can change
handle
this
that
one.
small of a number,
Effect and
but
then line
like,
up the universe.
I don't think so.
well, for maybe those three,
Yeah, there we go.
Yeah.
I don't know what else, I don't understand.
As a concept.
Handle that.
Entire class.
I think the supercomputer at NREL, those three constants is probably the maximum.
Well, I don't know.
You too?
But the computer associates to it, as you increase that number, the amount of storage and power exponentially.
Until you run out of money.
Yep. It's a
No,
money
like,
problem.
it's a big,
Are they
Well, I don't
I like thinking of problems.
so like,
Temporal.
many can do it, you're not
Very
small.
Well, we don't know.
You could, but you.
We wouldn't be there to.
Now, one scapegoat
Right?
or someone
Instead
who
of
think that the
100.
universe is deterministic, but we don't have.
So someone referring to probability, like if it's like
From their point of view, it'd be well,
Yeah.
it's deterministic.
so if you could be observing,
Has to be
but
observable.
not observing, or not likely to observe, because it's like only one habitable planet. You would expect to observe a universe where every planet
Yeah.
next door has another observer.
Not necessarily.
Not necessarily.
We only need the period for we have one
Yeah.
So oh, you see, I got 100 people on this
First, somewhere.
I think,
So we have to introduce a mind theism.
and actually, don't they say with the multiverse that universe in the multiverse has its own Big Bang? I thought that was the idea there.
There are a number, there's probably 30 different conceptions of multiverse. Some of them involve just within the initial expansion,
Okay.
inflationary
As far as
expansion
we can tell,
but at the very
probability
beginning,
of finding a universe that has life in it is 100%.
Okay. An infinite number at that point?
We can observe.
I don't know about infinite numbers, but those are different, there's some people who wanna postulate infinite numbers, which I don't know how you.
Yeah, that 2 weeks ago, we talked about that. But also, like, I think
Is that something else?
the reason
Someone there said that.
go to the multiverse is there's a vanishingly small
So,
probability of
basically,
constant.
The argument is that look how small the chances are
So
of a
if you
universe
have,
being created that could sustain
For
life.
every possible
And they're saying,
value of all those hundreds
yeah,
of
but
numbers,
observably, 100% of the universe is in.
we have different universes.
You should at least get one.
Right.
1 out of 10 of the.
And I think that's, it's not actually, it just feels like it.
But that's a really big one.
That,
To be able to obtain probabilistic levels. It's gonna be.
like he goes forward, he said that we should expect to do if it's
Thinking of numbers like we were using any equation, it's pretty much the same.
Because we know that, we know that either. In this case, we don't know whether or not there's
Well, so that's kind of like what you guys are ready. What he's getting at the end is what's the most reasonable
Way
cause?
more likely or whatever.
So
Okay.
that's really what this is about. It's like statistically the probability of getting this 1 of 1.
All right, there's also.
And I don't see how it actually.
Right,
yeah. Mentioned it before.
You're
You're saying that it has infinite chances, but
It's saying you're missing the point with the odds because as far as we can tell, 100% of the universe is the same life. 1 out of 1.
realistically, that would be
100% chance.
definitely doesn't support a naturalistic.
slightly faster than plane before, but it's slightly slower.
This is part of the explanation.
This is, you can't explain it.
So why even fizzle out after the first try?
Yeah.
It's also kind of 1 to the 10 to the whatever.
Well, and, I mean, even if you can make the argument that it happens in decent amount,
That would be true for initial
that continually, like,
Yeah.
no
the chances, if you do it.
All right, let's see how we do here.
Going,
I know you're under kind of like pressure to come up with something here.
Yeah.
There's a lot of deep thinking that goes on here, so so if you don't have something great, it's fine. But these are things that people actually do think about. Remember, the consideration here is which is the better explanation for the universe that we live in? Is it on naturalism or is it on theism? Pick those, let's just stick with those two options, all right? And so one of the things to think about with all of these arguments collectively, do any of these arguments actually improve the probability, the likelihood under naturalism? Are we moving the game at all? Or are we still kind of stuck where we were when we started? Okay, does that make sense? Okay, so let's see. So how do you respond to the observer effect? What do we say about that?
I'll try to field this one. Basically, what the argument is saying is that we've only observed one universe. We only can observe one universe, and that universe has life. So the probability of finding life in the universe or a universe is 100%. That doesn't account though for the local, what do we call them, local conditions, right? The probability of finding it in any given location in the universe, in a certain galaxy or a certain solar system, with a certain type of star. It doesn't really account for those things, right? I think we can observe even within our own universe that the probability of finding life is exceedingly small, 1 in many planets. That's I think our main pushback against this argument. But we've been struggling to think through this.
We also noted early on that this is a non-falsifiable claim. Like we can't observe other universes. So like, you can't say that the probability is 100% of finding life because there's no way of knowing. So this doesn't actually get you anywhere.
Okay. At least we can't observe actual other universes.
Yeah.
Okay.
We can imagine other possible universes.
Okay, and so this becomes the interesting thing with physics. This is what physicists like to do. And so science is not just about what I see, right? So we look for things like patterns and we formulate theories. and we construct laws to help describe the universe. Well, what are some ways that we can go about doing that? And one of those things is just simply playing these what-if games. And the evidence that we see is just evidence on paper. We know if on paper, if we alter gravity this much, what are going to be the implications for that? And so you don't have to see the actual universe to know what is going to happen. And so I think it's reasonable then to get at these fine-tuning aspects of all of these constants. We can do that without seeing these actual universes. And I think one of the things that this fails to do is ignore this idea of contingency versus necessity. Like Coach was saying, even within our own universe, we see there are aspects of life-sustaining planets that are very contingent. And if this observer effect only works if you are trying to stand on the hill that says all the laws that we see are necessary. They couldn't be any other way. But we have no good reason to think that. Okay? And so that's why we really can think about our universe as being fine-tuned, that we have to, all of these constants are within very, very small parameters. Okay, what about the universe is too fine-tuned? What do we say about that? God could make all kinds of universes, and why did he make one, that's fine-tuned? We could just have life everywhere.
Yeah, so this claim that like if God is all powerful, he would do this. It's kind of a dangerous claim because you're saying like if I were God, I would do this, and you're saying like God should do this, and you're questioning God for what he did. It's like you can't say what God would do because you're not God. First off, and then also it's saying like there's almost too much evidence. Like God should give us less evidence. If you lived in the world without fine-tuning, where life was more abundant and easier, you'd be like, wow, there's no need for a God. Like, it could happen on its own. Like, if you actually went into that world, you'd be like, yeah, there's less evidence for God. I'm less convinced by the fine-tuning argument.
Excellent. Okay. So I think one thing you picked up on here, this actually is sidestepping the argument. What we're trying to say with the fine-tuning argument is, okay, we are living in a fine-tuned universe. What best explains that? Is it naturalism or is it theism? And this sidesteps the argument entirely. The fact is, we live in this fine-tuned universe. What best explains that? Stay on, and this is common not to just fine-tuning argument. This is something to watch for in all kind of apologetic arguments, where we'll shift to some other argument to avoid dealing with the argument at hand. I think that's what this one does. So what explains the fine-tuning yours that we find in? And we can assent, yes, God could do that. I agree. But I think you're spot on, when we're saying, yes, God is free to create any kind of universe he wants to. He can do that, yes. But that's not the point here. No, but I think you have a right imagined thought to that. Is what is the benefit for having a fine-tuned universe over one that has life everywhere? And that people would say, well, if life is everywhere, then I don't need God to explain the universe. But the fact that it's so fine-tuned that everything has to be just so leaves open probably just one possibility, that there was some intelligent agent conspiring behind to get all of these things set just so. And this is, and again, you were spot on in saying what this is trying to do is get at the mind of God. So are you really so omniscient that you know precisely what God is going to think?
Just kind of like in a sense a theological point on this. In any argument, it's often to find people claiming, well, it'd be more convincing if God did it this way. He should have done it this way. And C.S. Lewis has a great point on people will never be satisfied, right? Because our hearts are naturally hard against God in a sense in our sinful state. But people will say, you know, oh, well, if God really existed, he would have made the universe small and focused on Earth, and maybe geocentric, so that we know he's about Earth and all this stuff. But if that was the case, then people would be saying, well, if God was all powerful, he would have made the universe huge.
Even
And
bigger
see
than what
all
we got
this
now.
stuff. And so there's just this idea, right, of never being satisfied with what it is now. So that's something to watch for when people bring up rebuttals like this.
Okay, what about the other side? Universe is not fine-tuned enough.
So along the lines of what Luke said, like you're kind of playing God here,
Summarize our
and
confusion.
you're kind of playing the value at like
I could try.
most
but I
life
barely
is
understand.
like the greatest thing. That's not necessarily what we
Yeah,
find.
that's
In our revelation from God, clearly there's a focus on humans and us, like chiefly in all the universe. Though God created everything, he doesn't care about some random planet 3 galaxies away. He cares about most about us here. So like
Oh, be careful there, because Colossians said God created the universe was created by him and for him. So even that lifeless planet out there, does God care about that?
well yes, and
It's not in his
Yes.
image.
He cares about it because he made it.
yes.
You know, but he made it for himself. So you gotta be careful there. But go on.
Yeah, so yeah, like the same thing. You're just trying to play God here and
Yeah.
saying what God would do.
Right.
But
Right. Same, but just on a different direction,
yeah.
right? So when we say, when physicists talk about a life permitting universe, realize what we're saying, what we're not saying. Life permitting doesn't mean there has to be life on every planet in the universe to be life permitted. If we have life on one planet, guess what? That universe is life permitting. Okay? We don't have to have life from one end of the universe to the other. And then this also looks a little bit at a scale problem. So we actually aren't, this isn't a question about fine tuning within the universe. This is like all universes. Okay? So it doesn't matter that there's places in our universe that are not fine-tuned for life. That's okay. We have one place, as far as we know. It is. So the question is, what are the chances that we're going to get any universe that would be life permitting? Okay, so we don't have to restrict ourselves to inside this universe, and we notice that there's not a lot of life everywhere. And so there could actually be good reasons why we don't have life everywhere. Hugh Ross proposes a few. You know, there'd be big problems. If everywhere in the universe there was oxygen, what would this universe be like? Yeah, well, I mean, for one, the light of the sun would not reach this planet because it would be refracted, interfering with all of those molecules between the sun and Earth, and we would not get any sunlight. Oops. Okay, so there really is some benefit to having big spaceless regions in the universe. We don't have oxygen everywhere. Okay, but we don't have to figure that out. Okay, so this one, no one got this one. So this is the idea of, are there deeper laws? Okay, so here's the problem here. One, what we're not saying is don't go looking for those things. Keep searching out physics. Do we have all the ultimate laws for the universe? No, we do not. Like I showed you, we keep finding more and more and more. Okay, even through my lifetime, we found lots of more things about the universe. So this actually becomes a little question begging. Okay, and this almost kind of becomes the God of the gaps for science. Well, give science long enough, and they'll figure it out. Okay, and then we'll have an answer to this. That's not a safe place. That's not a strong argument. Okay. So, and it again ignores, it sidesteps that question of, well, what does explain the fine-tuning of this universe? Okay, where did that come from? And so even if you look at the trend of things, as we keep accumulating more things, these 140 things on this list, what's the pattern that we notice? Does it look like the universe gets even more and more and more fine-tuned, or less and less? More and more and more. So it doesn't really look like we're going in that direction, all right? But even if it does, at the bottom of everything, and we don't know what we're going to find at the bottom of everything. Could we find this zero parameter law that sets all the constants for all the other ones? Maybe. But it looks like we're not heading in that direction. It doesn't look like we're going to find that very successfully. So for now, it doesn't look like that's the case. But even if we did, here's the question that we have to think about in terms of laws. So when we define laws, all we're doing is descriptions. What does that not tell us?
What ought to be.
Huh?
What ought to be.
Well, okay, yeah, what ought to be. It doesn't answer that.
Cause the rules to begin with.
Right. What caused those laws to begin with? We're just describing them. But who put it there in the first place? It doesn't look at that. That's one of those hard questions when we think about laws. Okay, what about this one? Probability problem. Looks like we've got even probability, right?
Honestly, we don't really know exactly what this is getting at, but it feels like it's just trying to argue for the idea that given enough chances, it would happen, and comparing that to where, well, God could do the same thing, but you're still getting to the same point where you just have this loop of, oh yeah, it just is going to keep trying, but in our experience, things don't just continually happen constantly forever and then just end, or like without end.
Oh, so this is not a science question. This is a math question. This is a probability question. And probabilities are always based on, what are the favorable conditions versus all the possible conditions. Okay, and in fine tuning, we're looking at, how many different universes could we get? Huge amount compared to the one we've got. Really small chances. So our naturalism doesn't look really good. Okay, so then we turn to theism, and we do the same thing. Okay, here's the unlikely universe that we've got versus all the possible universes God could create. Well, how many universes could God create? Would it be infinite?
Maybe.
Oh, you're not sure. Why are you not sure?
Because I'm not God.
Okay. Do we know? Of course, now we're not science here. Okay, this is not science. This is metaphysics. All right. So do we have any sense for the kinds of universes a God might create? Particularly a theistic God.
Real quick, under Christian theology, there would be certain universes God could not create, but that would still leave an infinite number of possible.
Okay. Would God be interested in creating any dead universes?
What would the purpose be?
Right? So I think without putting a number on it, is it fair to say that God would not create every possible universe that could be created?
Say that.
I think it's fair to say that. And we don't have to get an actual number to it. But what does that say in terms of probabilities? The probability of the naturalism, where everything's by chance. So you actually do have to look at every possible universe, versus one where there's a much smaller set of possible universes that a God would create. So how does that affect the probabilities? Well, it makes the probability on theism much more likely. And we don't have to put a number to it, but it's going to be more likely. Right? All right, let's take a look at this last one real quick. So what about the multiverse? The famous multiverse that they make movies about and everything. What do we say about the multiverse?
So I think this one is really kind of a last-ditch effort to just deny that we're, the only universe and that we were fine-tuned very specifically. I was telling Grayson that I think this kind of comes from like, oh well, I think we're, you know, either deterministic, but we definitely don't have free will. But when we do make a choice, there's a branching, and you know, every possible universe does exist. It's just we don't know about it because you know there's no way to know. And yeah, that's basically like just a concede of everything.
Okay, so, on some fronts, it does look like it's a very ad hoc argument, okay? It's not that scientists were looking at the universe and saying, I think because of what I look at the universe, there's a good possibility that there's a whole bunch of them out there. I don't think that happened. I think it looks more like they're responding to fine-tuning. And how can we get to a fine-tuning of a universe without God in the picture? So in some senses, it seems ad hoc. Now, to be fair, the idea of multiverse goes back a long ways. It's not a recent idea, and it's not anything in the Marvel universe. Okay, and so as scientists have been thinking about Big Bang cosmology, it does fit into inflationary cosmology, and some look at the possibility that at those very early seconds of our universe, that our universe actually splintered off into multiple universes, not just our one universe. Of course, that doesn't have any problem for our theology. God can make as many universes as he wants to. Okay? But here's the real problem. I think you hinted a little bit at it. Is there any scientific evidence empirical evidence for a multiverse?
You can't know.
By definition, no, right?
No, it's out there outside our universe. They're not detectable, measurable, so we can't deal with them empirically. And we can deal with them on paper, you know, and so we can theorize about them, but those aren't real universes, okay? And so does it fit in, does it help explain something about the expansion of our universe? So no one's come back and said, aha, this is the answer to that 10 to the negative 43 second gap that we have a hard time accounting for in Big Bang cosmology. It doesn't do that. But even if we do have a whole bunch of universes, it actually doesn't answer the question. It pushes the question further back.
Makes it a whole bunch of times harder to answer how did a whole bunch of these things come about instead of just one.
Right. So if there's this mechanism that could produce one fine-tuned universe that's life permitting, who fine-tuned that mechanism to produce the multiverses? So it really doesn't have, all it suffices to do is push the question further back, and really doesn't help us with the probability of these things. Okay, so it does not improve the favorability of naturalism over theism. All right, so real quick, some conclusions, and we'll wrap it up here. So, what I think the fine-tuning argument does serve as a defeater of naturalism. It really does look like the probability of having a fine-tuned universe under theism is much, much more likely than under naturalism. For naturalism, the probability is just vanishingly small. But I think we also need to think about in terms of deism. I think it's a defeat for deism. If we even let God in the door a little bit and say, well, he just kind of kicked things off at the beginning, but he doesn't really interact with this universe. Okay? I don't think that's the case mostly because of local conditions. We have to have all these fine-tuned things that have to happen over time. At different periods of time, certain things had to be just so. Which means, if you're going to let God in the door, what does that mean? That he had to have interacted with his creation at various times, not just at the beginning. So that defeats deism. So I think it does affirm theism, and I think that's important for us to get at with people. For some people, I think this is a beginning place. Now, is this the slam dunk argument for Christianity? Not even close. Not even close. But it's a beginning place for some people. But that they've got to get over the hurdle of whether a God exists or not before you can ever start talking about Jesus and Christianity. Because if you don't have a God in the universe, then there's no miracles and then there's no Jesus. Okay? But as soon as we can look at a universe and say, there must have been an intelligent agent behind here, we open the door for God in the universe. And we can open the door for things like miracles. We can open the door for incarnation, right? So I think that's important. And realize all kinds of people are going to push back against the fine-tuning argument. I think it's a really strong argument. It's hard to push back against, but you can push against it. And the thing is, it's not the only argument that we have. We have a whole host of arguments we keep referring to the cumulative case for the existence of God. Now, a couple weeks, we'll do another presentation. We're going to kind of do a survey of what are all of these different arguments. But we're not standing on one argument alone. We're not picking this one argument and say that's our go-to. I don't think we want to do that. I think we build a stronger case for the existence of God by pointing out to numbers, a dozen more different arguments for the existence of God. And together, with all these together, it's even more convincing. Okay. Well, there you go. We're way past time here. So I'll turn to you. I'm happy to hang around and chat.
Great. Thank you, Carl. Okay, a couple quick announcements. One is that Anchor is now this Friday. So it was supposed to be last Friday. It got canceled because we got absolutely zapped with snow. So it's this Friday. So I would super highly encourage you to be there. Salt Company is hosting it, which should be awesome. They've never hosted an Anchor before, so we're really excited to see what it looks like. So go support them. Be at Anchor Brown this Friday, 7 p.m. Thank you, Mason. That's the enthusiasm I need. Two is that next week's talk is from the one and only Daryl Doyama. So we're excited to have him back. He's going to be speaking. We don't know the exact name of the topic yet, but it generally will most likely be on music and the idea of music and musicality.
He and his son have been formulating this argument for the existence of God. So we love Daryl coming and talking to us about the ontological. So it's a little bit of a play on that. It's the ideological argument for the existence of God. So he and maybe his son is going to join him because they've kind of been working this out together. So that'll be fun.
Yeah, so definitely come support him and his son because that could be a super fun experience for them and for us to witness. Lastly, is that 2 weeks from now, lastly, 2 weeks from now, we're going to be whiteboarding again. And the topic is going to be, is there evidence for God? Yes or no? Super broad, super simple. The idea is that cumulative case for God. It's just having that discussion with people on campus of, is there evidence? If so, what does it look like? What are all the different kinds of evidence? So super good one. I would encourage you to be thinking about it, and questions like this tonight are super valuable to know. So I think that's everything. I don't think I'm forgetting everything. Cool. All right. I'll probably scream at you all before.
Where Anchor's gonna be?
Yeah, it's in Brown. So Brown 280. Is where Anchor will be.
Friday what?
Friday at 7 p.m. Be there or be square. I know where you live. I'm going to pray us out on that note. Lord, thank you for this evening. Thank you for each student here, the gift it is to be able to meet. I pray that you would just be with us as we leave here, that we would appreciate this universe that you have made just that much more, knowing all the things that go into it and knowing how many more there are that we have no idea about. As we continue to learn, we continue to be in awe. So may that ever be true. Bless us as we leave here. And in your name we pray. Amen. All right. Thank you, everybody. Have a good evening.